And a lot of people would put forward stories of how life began, or even RNA began, as a narrative, saying, first this happened, and then that happened, and then another thing happened, and another thing happened. And my friend Graham Cairn Smith would call them just so stories, because they sounded like the tale of how the leopard got its spots.
Hi, I'm Stephen Meyer, the director of the Center for Science and Culture here at Discovery Institute. We'd like to highlight for our audience a fascinating debate about the origin of life that's been taking place online. Before we get into that, I'd just first like to I'd like to find out a little bit about who you are and your background. You're an organic synthesis specialist in the field of chemistry, and you're also a nanotechnology engineer. Can you tell us about your work in science?
Okay, I'm a synthetic organic chemist. That's what my PhD is in, and I've been working in that area for 40 years. I also work in the area of nanotechnology, everywhere from drug design through interaction with cells, our little machines, nanomachines interacting with cells, through materials all the way to electronic memory, so over a large area of systems.
And you do some material science as well, I understand.
Yes, and so that's gotten us into the electronic memory and the molecular electronics and those sorts of things over the years.
And now I read in your bio you have over 600 peer-reviewed publications. Could that possibly be true, that anyone would have published that many scientific papers?
Well, actually, you're reading an old version of the bio, but yeah, it's true.
Is it more than that? It's more than that.
It's a little...
That's awesome. That's awesome. Well, we've been fortunate at Discovery Institute to be able to provide some funding for a small portion of your scientific work, but I know the work that you've done on the nano machine design has just been spectacular, and you've been able to design some little tiny nano machines that can actually kill cancer cells. Why don't you tell our audience a little bit about that?
So these are single molecule machines. They're about 1 nanometer in diameter. They have a stator and a rotor, and we shine a light on them, and they will spin at about 3 million rotations per second. We had originally designed, these are based on a Farina motor design. We originally put them in our nano cars. Then we took off the wheels and the axles, and we just directed them to certain cell types. It could be cancer. We've done it with bacteria, superbacteria. We've done it with fungi, and they'll drill
viruses as well, as I understand.
Yeah, that's some other newer work going on, and these will drill right into them and kill them. In the case of a virus, it'll deactivate a capsid, but in the case of cells, which are far more robust, it will kill them. And we have a whole new generation of nanomachines that we've redesigned so that they're activated by light. They're always activated by light, but in this case, they're activated by near-infrared light, and they work more like a molecular jackhammer than like a molecular drill.
That's fantastic. When you say we, is this your research group at Rice University?
Correct. When I say we, it means that I don't do anything. My students in the lab are the ones that do this.
Yeah, well, we all know how science is done, right? That's great. And you've generated quite a number of patents from your inventions as well. I read, and this may be underestimated as well, something like 140 patents. Is that right?
Yeah, it's some number like that. And,
okay.
And again, it's over a broad array of areas, and we've started, I think it's 12 companies now, and they're moving along. Some are moving along better than others, but they're all moving.
That's fantastic. And so, as I understand it, some of your interest in the origin of life question is derivative of the work you've done on these nano machines. In particular, learning just how hard it was to make simple nano machines, and then realizing that inside cells there are much more complicated molecular machines, and got you thinking about how plausible some of these chemical evolutionary scenarios actually are. Can you tell us a bit about the development of your thinking on that?
Right. So the thinking was actually at a meeting that you had invited me to. I guess it was about 6 years ago, and I started looking at cellular structures through some presentations and claims that people were making, and it turned out to be really frustrating to me that none of this could could easily have happened is the way that people were supposing. And then it was actually David Berlinski that asked me to write an article, and I started looking into the origin of life and the chemical systems of and the chemical claims on origin of life, and what people who work in the area of origin of life have done. And the claims went way beyond the work that was published. And so that's what got me writing about these issues. And then the more I would write about this, the more the people in the origin of life community would contest with me. And so it's just kind of taken off from there.
You found yourself in a debate.
That's right.
Yeah,
I mean, because of you, actually.
I'm very sorry to have ruined your life, Dr.
I had a very pleasant life, just minding my own business and doing my own research.
Inventing cool stuff, right?
Yeah.
Just for our audience's sake, I use the term chemical evolutionary theory, but let's provide a little background. Most of us are familiar with the theory of evolution associated with Darwin or modern neo-Darwinism, and we can think of that as biological evolution, in which the scientists are attempting to explain how new forms of life have arisen from simpler, earlier forms of life. But chemical evolution is the attempt to explain the origin of the first life from non-living chemicals. And so what you were reacting to was papers by scientists who were claiming to simulate some part of that process in the laboratory. Is that right? Getting from the simple molecules to an actual living cell.
Correct. And then claiming that they had done everything that needs to be done, and now Darwinian evolution could take over from here. It was really a bunch of nonsense. And even the term chemical evolution, I had never even heard until I came around you. And then you started mentioning these things that are in the literature, and people use this term chemical evolution, which is a bunch of nonsense, because chemicals don't move toward life. They have never been shown to move toward life unless you have a living biological entity, which could be a person, pushing them in that direction. And human beings have never been able to make life in a laboratory. And so surveys, we took surveys after that, and the world thinks that scientists have made life in the laboratory, both simple cellular life, which is wrong, and even larger organisms, like even frogs. Many educated people think that scientists have made in the lab. So
when you say many, Jim, I mean, what kind of percentage of the general public, how large a percentage of the general public has been beguiled by these claims?
Well, about 30% of the general public. When I say general public, I mean 80% of the people having at least some college education, either an associate's degree right through to a PhD. 30% believe that they've made frogs, that scientists have made frogs. 2/3 believe that scientists have made simple things like a bacterium in a laboratory. So we're not even close. I mean, not even close. We haven't made any zero. It's actually zero. We've made zero structures that are needed for a cell when we are using what's called prebiotic chemistry that would be available on an early Earth. What people have done is they've taken a cell and they've added genetic material to a living cell, but nobody has taken taken the basic chemicals and put them together to form any of the needed structures of the cellular system. Mm-hmm. None of the building blocks. There's 4 classes of compounds. They haven't made any of those 4 classes of compounds. They haven't even made the building blocks to build those 4 classes of compounds when you're using what's called prebiotically relevant chemistry, meaning chemistry where you're not using human-made additives, pieces that you've taken from biological systems. Now, even if you take pieces from biological systems, none of that, nobody's ever gone from no life to bring about life. Nobody's even taken a dead cell and brought it back to life, because you would certainly think that a resurrection has got to be easier than a de novo synthesis. Nobody's ever done that.
So here's a quote I'd like to get you to react to. This was, as you know, I did my PhD in the philosophy of science, but my PhD was on origin of life biology. So it's an interdisciplinary subject. And my master's advisor and one of my PhD examiners was a historian of this field, of the origin of life research. And she said this: at the heart of origin of life research lies a fundamental question. what is it exactly that we're trying to explain the origin of? You mentioned just a minute ago that there were 4 fundamental classes of molecules inside cells. So my advisor's name was Harmke Kaminga, and her point was, if we want to explain the origin of life, we have to look at what life is like today, because that's the thing, the origin of which we're trying to explain. So what have we learned about the cell itself since, say, Darwin's time? And what are those 4 classes of molecules out of which cells are composed?
Well, the 4 classes of molecules, one is the lipids, and those form a lipid bilayer, the outer structure around a cell, the cell membrane or the cell wall, depending on whether you're speaking about a mammalian cell like a eukaryotic cell or a prokaryotic cell like a bacterium. And then you have to deal with the amino acids, and the amino acids are there's 20 basic amino acids that are found in nature. You have to make all 20 of them. 19 of them have stereogenic centers in them that have to be controlled. And then you have to be able to polymerize them into the proteins and enzymes that are needed. You have the sugars. These are often called the carbohydrates. And then the polymers of those, which are the polysaccharides that make up the cell. And then you have to have the nucleic acids, which is the DNA and the RNA, which involve first taking a sugar ribose or a modified sugar, a deoxyribose, hooking on it a nucleobase, and then having a phosphate group on it, and then polymerizing those to get DNA and RNA. So the 4 classes of compounds are those nucleotides.
That make the nucleic acids of RNA and DNA.
Correct. And then it's the sugars or the saccharides, sugars or saccharides that make up the polysaccharides. And then you have the amino acids, which make up the proteins, and you have the lipids, which make up the lipid bilayers. All of those classes of compounds have to be made. None of them, I'm telling you, 0 have been made in homochiral form, which means 1 enantiomer, which is what you have in nature, using a prebiotic synthetic method. Okay, so none of them. Then on top of that, you have to build lots of higher order structures, and those have to be assembled into more higher order structures just
out
to get
of those 4 classes of molecule.
Correct. Just to get the simplest of cells, you'd have to have that. We don't know how to build any of those higher classes of structures using anything that's prebiotically relevant. Now, even if you were to use non-prebiotically relevant, just human ways of construction, we can't even build those higher order structures. So, for example, we don't know how to make a lipid bilayer where the outer layer is different than the inner layer. The outer layer has mostly saturated systems, which means alkyl systems. The inner layer has a lot of unsaturated systems, which means a lot of double bonds or alkenes on the inside. In nature, that's done using enzymes called flippase enzymes. We don't know how to do that in laboratories. So there's all these control structures, and then you have to have synthetic systems that can build polynucleotides, that can polymerize these. You have to have enzymes to do this. We don't know how to do any of this. So we're just really stuck. And the general public has been duped into supposing that this has already been done because of the claims of the scientists themselves. And then after they publish their papers that have very wild claims in them, that go way beyond the data in the paper, which is what I'm exposing in my series, they will then ramp it up by speaking to the press, making really wild claims that are an order of magnitude even higher, and then linking this to Darwinian evolution as if they've got this thing solved. And that's what I'm calling out, and that's what I'm going to do, and that's what we're doing in the series. We're just calling it out.
Excellent. So 5 or 6 years ago, you start looking into these claims about origin of life research and these prebiotic simulation experiments. And as an organic chemist, an organic synthesis specialist, you say, hey, the chemistry doesn't do what these guys are claiming it would have done on the early Earth. And so you began to critique this, and you made you had some lectures online, And then some people started to push back. And one of the guys that pushed back apparently was someone who has a handle online as Professor Dave. His name is actually Dave Farina. Can you tell us a little bit about him? Because I know that the new series that you're coming out with is responding in part to him. And I'm wondering, what is Dave Farina's background in this debate?
So Dave Farina he calls himself a science communicator. So he makes videos, a lot of scientific videos that explain things to the masses. And I've always said good things about the fact that he's making scientific videos for the masses and explaining to school kids the different scientific topics. I never watched any of his videos up until recently. I never watched any. I didn't even know who he was. But he came.
So you didn't you didn't start this argument. Apparently, he attacked some of your lectures. Is that how it got started?
Right. Well, actually, it was because of you again, Steve.
Oh my goodness!
You invited me to a Discovery Institute talk in Dallas a few years ago, and I gave a talk that I guess really teed him off. And so he made a 45-minute video based on my 30-minute video, saying many things that were just categorically wrong scientifically. And without any ad hominem attack, I made a 13-part series. Actually, it's 14 parts. One of the parts is A and B, but say a 13-part series where I went through a basic teaching on the chemistry that's needed for origin of life. And that's been up for 2 years now. And based on
something we highly recommend, by the way, it's excellent. Yeah.
Right. So if you want to learn about the chemistry that's needed for origin of life, you can learn it there. And then based on that series, he came out with a 2-part series critiquing my 14-part or 13 or 14-part series, where he came with a lot of ad hominem attacks. But I'm not going after him anymore at all with ad hominem attacks. I'm just critiquing his science. But amazingly, Dave Farina got every slide wrong in his first presentation.
Jim, is he an origin of life expert himself? What are his qualifications to be weighing in on this discussion in this issue?
He has as much qualifications as we have pieces made for building cells. 0. He has no qualifications for this. What he's very good at is speaking extremely authoritatively, and in many cases that's an advantage. But
so he doesn't have a PhD in a relevant field, chemistry or biochemistry or anything like that? Or?
No.
Okay,
he doesn't.
So he's a
musician, actually. He's a musician.
But he's a science. Is he a science teacher?
He calls himself a science communicator.
Okay.
Now I'm not critiquing any of his other videos. All I know is that the man doesn't know any chemistry because he succeeded in getting every slide wrong. The science on every slide in his first series, in his first lecture, was wrong. His second one, where he had a 2-part series, he succeeded again in getting the science wrong on every one of his slides. Now, think about this, Steve. How hard it is to get every problem wrong on an exam. And he's trying to get it right. But let me say up front that I have to thank God for David Farina. If it had not been for him, I would have just continued doing my own thing. But because he came out with this, I had to come with this 13, 14-part series describing everything so that the general public can understand the problems.
Well, that leads to my next question, because if he's not a qualified expert, and that would be fairly obvious maybe to people watching these videos, why did you feel the need to respond to him? Aren't you punching a little bit below your weight class as one of the leading organic chemists in the world?
Right. So at the time, I had a YouTube channel with about 10,000 subscribers. He had a YouTube channel with nearly 1 million subscribers. I thought, wow, this has to be responded to. He has 1 million people that subscribe to his channel. Now, since then, mine has gone up to I don't know, just something around 40,000. His has gone up over 2 million. So his is more than doubled. Mine has about quadrupled. So, but
But it's going to take a while for you to
sheer
catch up with
numbers,
some of that, right?
are
Yeah.
very different. So only because he's speaking to so many people, I thought it was worthwhile. And
So you felt a kind of scientific responsibility to combat a disinformation campaign that he was single-handedly waging against you and others who are critical of these experiments. Is that?
That is correct. Now, I will say on his second series, he brought in 3 so-called experts in the area of origin of life. Each one of them was a synthetic chemist, 2 synthetic organic chemists, 1 synthetic inorganic chemist, and he had them talk about their own work. 2 of them came on and he spoke to them in a conversational format and they described their work. One of them had made a video for him on some previous topic. He had inserted it as if that expert were responding to my video, which he was not. And I know that because he's a friend of mine and I talked to him. And all of this is going to be exposed. I don't think he was very honest in the way he made the presentations, but in any case, bringing on the experts was good because now in a social media forum, I could then contest with them and show how their own data.
So you don't have to punch below your weight class anymore. Right. You can take on experts, and which has been your concern from the beginning, as I understand it, is that the experts who present their prebiotic simulation experiments to the public through the media are grossly overstating the significance of what they've achieved in the laboratory. Is that correct?
That is correct, and so Dave Farina has contested that it's the press that ramps this up, not the origin of life researchers themselves. So this was perfect. I could go after the very articles. I'm not in this new series that's coming out that is already launched, and several of them are already out now. In this new series, I'm looking at the exact papers that Dave Farina put up there and the exact experts, what they put up there, and critiquing their own work, doing the job that the reviewers of those papers should have done, right? And just exposing from their own work how their own work screams out, this is not how life could have formed. It couldn't have happened this way.
Because the chemistry doesn't move in the direction that they say it does without extensive interventions and assist from intelligent human chemists. Is that the essence of the problem?
That's one of the problems. Because it's even with all their human interaction, they don't get what they say that they've gotten. They never get homochiral material. In most cases, they get vast mixtures that they themselves are unable to use. Yet they suggest that if this were on an early Earth could take it and take it on from there. You can't use it from there because what happens in chemistry, if the compound that you want is heavily contaminated with a lot of compounds that you don't want, even lightly contaminated at times, you can't use it because it gums up the works. It interferes. It's interfering chemistry. And so chemists go through great lengths to purify it. But in these cases, their mixtures are so bad that they don't even go to the great lengths to purify it. They just see it, they notice it with very
they notice a compound that they want is in this vast mixture of other things that have been produced by their simulation experiment, and they say, since it's there, I'm just going to go buy that off the shelf and start over in the next step, as if you could get from the conglomeration of all those different compounds to the purified starting point that they need without some intervention of an intelligence.
That's absolutely right. They're buying it, and the compounds that they buy have been isolated from already living biological sources or sources that have been made using biologically relevant chemistry, meaning that you have enzymes that have been made biologically, and you're using that. So it's a total cheat. You go along and it's a total cheat.
I want to stop press right there. That's really significant because the whole idea of prebiotic simulation experiments is that they are simulating how you get from non-living chemicals to living chemicals. But if in order to do that, you have to take a compound derived from a living cell and use that to simulate how you get to a living cell, that's a profound cheat, because the whole idea is you need to show how you get from simple non-living molecules and chemicals to chemicals that are relevant first to life and then finally to a living organism. But if you're pulling stuff out of a living organism, you're defeating the whole purpose of the experiment itself.
That's right. It's a cheat at every step. They cheat at every step. It's chemically cheating at every step. It's scientifically cheating at every step. In no other field of chemistry could you get away with this. And yet,
because after all, what they're trying to simulate is how undirected chemical processes could produce life. But if to produce even the substrates of life, the compounds out of which life, the different classes of molecules out of which life is formed, they have to themselves intervene repeatedly and intelligently, then they're not simulating an undirected process. They're arguably simulating the need for a directed process. And you might call that intelligent design.
Yeah, but even with all their intelligent design, what I'm saying is they don't get it.
They still don't get there.
They still don't get it. And so the next step, they have to buy some more of the next thing. And the next step they have to, because in every step that they do, they don't get what they want. And this is what I'm exposing on the series. Watch this thing and just watch the things that they put forth as if it's intelligently, as if it's done without any direction. And then even with all their direction, they can't use what they get. Chemistry is really tough. And then they make these crazy wild claims that I'm calling them out on.
Yeah. You had a predecessor in this role in Origin of Life research. He died a few years ago. His name was Robert Shapiro. And he was also an organic chemist. He wrote a book, A Skeptic's Guide to the Origin of Life, back in the 80s, but continued to publish papers in Origin of Life research right up to the time of his death. I attended a conference with him in 2010, I think. And people in the field respected him, but they didn't like him because he was constantly exposing the same kind of things that you're exposing. And they used to call him Dr. No. But his point was the chemistry doesn't do what you claim it must do to spontaneously or in an undirected fashion form these essential building blocks of life, or the essential categories of molecules. So you're in good company. He's just passed on. So Shapiro would, I think, approve of what you're now doing.
All right, so
let's talk about your new. You've taken up his mantle. Let's talk about your new video that's just come out. I've just seen it. It's fabulously engaging because there's a lot of back and forth. You definitely give the other side a chance to make their points. But in this video, you're responding to Professor Dave again, but you're also responding to one of his experts, because I think you feel a bit more comfortable taking on another chemist because it's a more fair fight, right? So the chemist that you're challenging is Lee Cronin. And tell us a little bit about what he has claimed about the origin of life, and specifically the claims he's made both in a media context, but also in his scientific papers about what he's been able to achieve in the lab.
So Lee Cronin is a professor at the University of Glasgow, and he has made claims that this primordial soup model, where you have a bunch of chemicals in a pond, in a lake, and there's lightning strikes, and those chemicals could somehow come together to form the initial cells that are going to then end up participating in Darwinian evolution. So I have called him out on that. I've questioned him on that. And on the first video, I give him plenty of time to speak because he feels that in my series, I didn't really give him a chance to speak because I cut him off. Well, the reason I cut him off is because he doesn't say anything of any substance. And so this video series, I really let him speak, and the guy just hangs himself because he says nothing. He says nothing. He gives you no chemistry. No, he talks about royal flushes. He talks about flipping coins. And we keep wanting to see the chemistry. He doesn't give it to us. So I finally, in a debate, in a conversation that I had with him on Justin Brierley's unbelievable program, I had gotten to come around to the point where he confessed there were small molecules, there was life, it happened, but we don't know how. And he comes around to the point where he says exactly to that. That was a big big step for him to come around to the point and admit we don't know between the small molecules that must have been present on an early Earth to where life came from. We have absolutely no idea how that happened. However, even though he admitted to that, he continues to go around putting these papers out, speaking about these experiments. And so he brings on these experiments. And so that was in the first video, I got him to come around and to confess that we don't know how. But in the second video, I let him speak even more. And he speaks about his own work, and as if it's somehow suggestive of life's origin. And I just dissect his work. So that's what I'm doing.
Let's talk first about the interaction on Justin Brierley, and then let's get into some of the specific chemical claims that Cronin does make in his own work. I thought the interaction on Brierley's program was very telling because Lee was responding to a caller who wondered if, in portraying his understanding of how life began on Earth, he was conveying what was widely understood by the scientists, and essentially that there was some kind of warm little pond on the Earth. There were molecules in the pond. They interacted, and eventually, because of these interactions, they developed some sort of self-replicating system and finally a cell. And Cronin said, yeah, that's basically it. And then you called him out on that and said, well, wait a minute, that isn't it. We don't have any idea how you get from those inorganic or small molecules in a prebiotic environment to a first living cell. And then in response to you, he said, well, I didn't say that we did know how. All I said was that there was a condition on the early Earth where there were the building blocks of life, some sort of small molecules. And then later, after the cessation of something called the late heavy bombardment, the meteorite bombardment of the Earth, life arose very quickly after that. And those are established facts. And so you're misrepresenting me. I didn't claim that we knew how, but you said, well, wait a minute. That's entirely the point. Do we know how? And he finally admitted that we don't know how you get from A to B. He said, all I was claiming was that there was a point A where we had small, non-living chemicals, and then there was a point B where we have a living cell. But that's a trivial claim. And by defending himself in that way, it sort of had the effect of obscuring just how important this concession was, because the real important point is, do we have a theory about how you get from A to B? And he acknowledged that we don't.
Correct. He acknowledged that we don't. And yet he continues to do his research as if it is pointing to a methodology to go from those small molecules to life.
Or a plausible theory by which that could happen.
Right. And he's claimed on many occasions that he's going to make life in his laboratory. So he feels that he's actually doing it in this direction. Now, it's heavily guided, but he claims he's going to do it. But he keeps missing his deadline.
Yeah. So let's talk about some of the specific claims that he makes as a laboratory chemist on this. He makes quite a lot out of something called the Formose reaction, and claims that can be readily simulated and produce sugars. Tell us about the Formose reaction and what origin of life researchers such as Cronin are saying about it and how they portray their work on it as giving plausibility to these origin of life scenarios.
So with the Formose reaction, you take a small molecule, which is a small molecule that like acetaldehyde, that has an extra hydroxyl group on it. And it's actually not easy to make that compound. Not that easy, but
so even the starting compound is a difficult thing to
it's
make.
Really not that easy. And in
would
fact,
it be readily available on the early Earth?
Some people claim that it's readily available through reaction of formaldehyde and sunlight. It's, even Steve Benner, who's an origin of life researcher, has said that this starting material is actually very hard to make. Mm-hmm. And but we'll give him that. So he takes this.
Okay, concede that for the sake of argument. Yeah.
Right, because it really doesn't matter. He's just going to get hung on this thing anyway. So he takes this and he reacts with calcium hydroxide, and he keeps feeding in more material, and he confesses that within seconds, he says his exact words are, within seconds to hours, you get billions of compounds. This is exactly what I have been saying. You get so many compounds it becomes unusable. He even says
wait, just a sec. So getting billions of compounds is not a good thing. It sounds like it's a good thing initially, but that's not a good thing. If you're why not?
It's a very bad thing, because now you have so many compounds in there. Even if you have a little bit of the compound you want, it's unusable because it's in a sea of many other compounds that would gum up the works, that would interfere with any of the next steps that you wanted to do.
Oh, so it's going to react with other compounds that are also present and go in a direction that's not life relevant. Is that
right? And so what I have long said is that when you have this sort of chemistry, you get so many compounds that what you get is absolutely unusable. So he shows this scatter plot using something which he's called ultra performance liquid chromatography, where you see lots of little dots. That each one of those dots is actually multiples of compounds. And his argument is, well, I can just keep adding the starting material, and it self-purifies. It gets less messy. So I went right at his own data, and I showed that what he was doing is, he says that he was decanting off. He was using the supernatant, meaning the material that remained in solution. He didn't analyze what had polymerized and fallen out of solution. And he says that it was self-purifying, but he was only taking 70% of the reaction mixture and leaving 30% of the reaction mixture untouched because it was precipitating out. So he was undergoing a self-purification. By the researchers were doing this, yet he argued that it was self-purifying.
Just to interrupt, Jim, sorry, for our audience's sake, the supernatant is
what's in solution.
Okay, and this is not something you want. Is this
No, he took that. He didn't take any of the polymerized garbage that was at the bottom. So he says, you see, it's purifying.
Oh, I see. Okay.
Well, you left 30% in the bottom.
So it wasn't self-purifying. The chemist was doing the purification.
Right. And even with all his purification, he still had billions of compounds, at least billions. If he had analyzed the other parts, he would have had trillions of compounds. But yes, the researcher was doing the purification, not the chemistry itself. But even if I give him just the supernatant, the portion he wanted, did he ever use any of those compounds? He could not, because it was not, even with all his tools, he couldn't separate it. He even confesses later in the paper that I couldn't even check the authentic standard against that mixture because it was too complex. Mm-hmm. This is so complex, it's totally unusable. So what he did is he showed that the chemistry that he was using was totally unusable. And interestingly, he used calcium hydroxide, which would be available on early Earth. It's a fine system to use. But Dave Farina didn't even notice. Dave Farina tried to discount the use of calcium hydroxide earlier on in his video. And then he brings on this guy who uses calcium hydroxide. It's really kind of ironic.
And what's the significance of the calcium hydroxide?
You need a base. Okay. It's the base that you need for this oligomerization reaction. He was trying to make ribose. Ribose is the key sugar that you need in order to make DNA and RNA. Okay. Right. And for DNA, you need deoxyribose. He was trying to make ribose because he wanted to ultimately make RNA, and he could not access any of the ribose. Sure, there was ribose in there, but he had all the other enantiomers and so many other compounds. It was totally unusable.
It was a jumbled mess then. Yeah.
Correct. It's like if you wanted to write a book and you dumped out a bunch of letters. I mean, a big box of letters, and you said, my book is in there somewhere, because if you were to arrange those properly, you would have my book. But no. It's totally unusable. It's unusable because you have such a mess in there, and that's exactly what it's like. So you take your book, Signature of the Cell, and you cut it up so that you brought it back down to all the base letters. You cut out every letter. Have one of your kids do that or something. Cut out every letter and then throw it in a box and claim that your book is in there. No, it's totally unusable because in a sense, your book is in there, but you can't put Humpty Dumpty back together again.
The material this is the problem. The material substrate is there, but the arrangement, the specificity of arrangement of the parts, which constitutes the important part of the book, namely the information, is is not there.
It's not there.
There's okay, so this is the ribose. He's trying to get ribose, and then he also wants to show how it could be linked together to form DNA and RNA, and that step also poses a problem for him.
That poses a big problem. He doesn't do it on this video. That's something that Benner does in the video, and we'll get to that later. The other thing that he does is he tries to make polypeptides. He tries to take amino acids, which he buys, which come from a source that's using biological-like chemistry to make these. And he's saying it's not hard to polymerize these. He says, in fact, it was easy for him to polymerize these. And I've long argued that they don't polymerize in water. Dave Farina says they do polymerize in water. So I show, so what he invites on Lee Cronin, and Lee Cronin himself confesses in the very article that Dave Farina showed that Lee Cronin cites. In his very article, it says these don't polymerize in water, and he shows.
This is not a contested point in chemistry. Is it? People know this, that water has a negative impact on polymerization reactions, especially with amino acids.
Everybody knows this except poor Dave Farina doesn't know this, and he keeps contesting that it does polymerize in water. It does not polymerize in water, and he says the reaction is exergonic. In the very paper that Lee Cronin shows, he shows that the delta G, this is the free energy of formation of the reaction, is positive. It is the opposite of exergonic. It's endogonic.
Which means it's not going to happen spontaneously.
It's not going to happen spontaneously. Lee Cronin says it in words. He says it in equations. And Dave gets it the exact opposite. This is what I'm saying. The poor man is a victim. He's a victim of the things that these people say, and he's a victim of his own inability to translate these articles. He's to read these articles and make sense of them. And he says something is exergonic when he's looking at a paper that says it is not exergonic. The equation's right in front of you. That is like looking at a page and saying it is black when it is white.
An exergonic reaction is one that would happen spontaneously because there's enough energy available in the constituent parts of the constituent chemicals to drive the connection between them. Is that essentially
it means
what we're
that
talking
the enthalpy and the entropy together, along with the temperature, would allow this reaction to occur. The delta G0 would be a negative. It would have a negative sign in front of it, a minus sign in front of it.
And so it would occur roughly spontaneously?
Correct. Okay. It would occur under these conditions. But it has a positive sign. It is right there in the paper. It shows a positive sign.
In fact, it has a positive sign, which means it's
endogonic.
And therefore is not going to occur spontaneously.
Right. And Dave thinks he's arguing that it's going to occur spontaneously. So what Lee Cronin does to get around this, because Lee Cronin knows that delta G is positive, smart guy.
Right.
So what he does is he dries it out. He takes away all the water. Dave never noticed it. He's saying these are polymerizing water. In fact, Lee Cronin says, when I dry it out, I force the molecules together by taking away all the water, and I'm heating it up. He says he's heating it up to simulate how it's warm in the daytime and then cooling down, cooler at night. But if you read the paper, which Dave was unable to, he's heating it up to 130 degrees centigrade. That's over 250 degrees Fahrenheit. There is no daytime, nighttime like that, because if there were daytime, nighttime like that on early Earth, daytime got up to 130 degrees centigrade, that is sterilization temperature. That kills everything. So you could never get life to begin with. If life ever tried to form, it would be over. Game over, it's toast. And
so you've got a classic chemical
toast.
You got a classic chemical catch-22. If you try to achieve polymerization in an aqueous solution in water, the presence of water is going to make it energetically unfavorable, and you're not going to link up the amino acids.
Correct.
If you heat it up and to dry it out to get rid of the water, you're going to reach sterilization temperature, and you're going to destroy anything you might have linked together once it's linked together.
You're going to destroy any life that would want to form. If you're going to argue that your days get up to 130 degrees, then everything is going to end up decomposing. But even the polymers that he got were not polypeptides, because what happens is is you have a, a carboxylic acid and an amine on the other end. And what happens is these might begin to hook up, but you also have an extra linkage there. That extra linkage competes with the position of these two, so you get a mess. You get something that nature will never make. It's something that is
and
not
which is not
used.
life and not life friendly.
It's not
not
correct.
life usable.
It's not life usable. Now, nature might have some of those cross linkages, but never by ribosomal synthesis. Never in order to begin to make the cell. It's in the higher order structures that you might get some of those linkages to occur. But never at this stage, because now you've changed the whole, what would have been the polypeptide chain. It's gone. It's toast. It's game over. What
So
he
you need
demonstrated is that it could not have happened this way.
Yeah, right. So those linkages that you want, I think, are called peptide bonds. Is that
Correct.
right? So you want exclusively peptide linkages, so you get a nice
C terminus
linear
to N terminus, it's called.
Okay.
The C to the N terminus.
Excellent.
But
but you need to have those exclusively if you're going to form a functional protein.
Correct.
And you're not. And what he generated in his simulation was not exclusive peptide linkages, but other things coming off at odd angles that were connecting at that other linkage site.
Correct. It was a bunch of nonsense. It was like your book cut up into pieces again, and then your child started gluing the letters together and saying, "Daddy, here's your book." You'd be like,
and some of the letters
No.
are at odd angles to the other, not even lined up in the way
exactly. They're upside
created.
down. They're backwards. They're flipped over.
Okay.
Everything doesn't
Good
work.
analogy. Good
Yeah,
analogy.
and so you can say if they gave your book, Dad, you know, I did cut it up, but here's your book back. I glued it all back together. You'd be like, it's not the way it works. And that's exactly what Lee Cronin did. And he speaks about this as if he's made polypeptides. That's the problem that the researchers themselves.
So the simulation is actually showing the difficulty of making life-relevant molecules. It's not showing the plausibility of making life-relevant molecules via an undirected process starting with plausible prebiotic conditions.
Right. So Lee Cronin's own work screams out, this is not how life has formed. This could not be how life has formed. So one of the papers that he talked about was the foremost reaction, which showed that it was totally unusable. The next paper he made, what he was saying was polypeptides. So first it was sugars. The next one was proteins or polypeptides or enzymes. He showed that it could not have happened that way. And if he wants to argue that early Earth is heating up reactions to 130 degrees, no life could have ever formed anyway, because
under those conditions.
For sterilization, you heat up to under 130 degrees centigrade. You heat it up for 15 minutes and it's sterilized. He's heating for 15 hours at 130 degrees. I mean, it's a joke, is what it is. It's an absolute joke. And for him to have spoken about this, and for this to have been accepted in the chemical literature as if it were prebiotically relevant, it's because that community, the origin of life community, is self-reviewing. They're reviewing each other's papers, and they're getting these things in. Never would this be accepted. And well, I had it.
Oh, sorry to interrupt, Jim, but that's an interesting point, because Farina attacks you for not having the right kind of expertise to be weighing in on this subject. But it is often people from outside of a research community who can spot some of the assumptions and the methodological practices that are either inconsistent or incoherent, or in this case, contrary to basic knowledge that we have about chemistry. So is your expertise relevant, or what should we say about that?
If you're going to make molecules, organic molecules, that's kind of what I do. I mean, this is what I've been doing for 40 years, more than 40 years. And so
they're actually, they are doing simulations of chemical processes that they say move you from simple, non-living chemicals to life-relevant chemicals that would be necessary to make a cell.
And it's not true.
So, and that is, in essence, a matter of organic synthesis, right? So this is right in your wheelhouse.
Synthesis. And Dave says synthetic organic chemists can't get this, but then what does he do? He says synthetic chemists can't get this, so he invites on 3 synthetic chemist experts. Two of them being synthetic organic chemists, one being synthetic inorganic chemist. So it's full of irony throughout the whole thing. The poor Dave. I mean, he's a victim of what these guys write, and he's a victim of his own lack of knowledge that he tries to talk about this.
But I think both you and I appreciate the fact that he's taken this subject on. And I appreciate you having taken it on at the beginning. I had a supervisor in Cambridge who said that beware the sound of one hand clapping. If there's an argument on one side, there's bound to be an argument on the other. And we've had for years these claims offered to the public as a kind of uncontested scenario about how life began. And you challenged them, taking up the mantle of Robert Shapiro and others, but you challenged these guys. And that was good, because now we had two hands clapping. We had an argument, we had a counter argument, and we could evaluate the strength of the initial claims in light of your critique. But even better, then Dave Farina came along, enlisting some experts, but challenging your critique of the original claim. And now with both of those arguments out there in the public sphere, I think our audience and your audience and people interested in this topic have the ability to evaluate the arguments for themselves and to see who is more credible, and if they know a bit of chemistry, to find out whose claims about the chemistry are more accurate. So I actually appreciate the fact that he's weighed in. Sometimes his language is a little salty, and he does get a bit personal and insulting, but we now have a spirited exchange about a really important debate out there in the public, whereas before, as you've pointed out, it was a matter of a few experts making claims in technical papers that would then get exaggerated in media reports, and then into the textbooks they would go. And we all had the sense that, the Miller-Urey experiment in 1953 heralded a series of experiments that showed exactly how life arose from non-life without any intelligent direction whatsoever. And in fact, we don't have any experiments that demonstrate that that's the case. But, well, Dave Farina says we do. So we now have a debate, at least.
That's right.
And I think that's a good thing. Yeah.
Yeah. And the third article that Lee Cronin brought in was, he talks about autocatalysis, which Dave...
Is this the bit about the oil droplets and the?
No, this is before the oil droplets.
Okay.
He takes an inorganic complex and he does something called autocatalysis, where it makes a certain structure, and that new structure becomes a catalytic template for the structure, for the building of a larger structure over it. That becomes a catalytic template for a larger structure over it. And Dave feels that this has high relevance for origin of life. The very claims of this are going to be debunked by some of the other experts that he brings on to cite it, and Dave didn't even notice it. But let me just say that what Lee did is with an inorganic complex that he calls rust. It's very much like rust. It has nothing to do with the compounds that are life relevant. With an inorganic complex, you can get, because of the symmetry, it allows you to do this more easily. And this was demonstrated 100 years ago, about 100 years ago, by a man named Oswald, demonstrated this. Lee is now doing this and saying it has something to do with, it's relevant to origin of life. It has nothing to do with origin of life. This class of compounds, because of their symmetry, allow this type of thing with much higher fluidity to form, to undergo these autocatalytic reactions. But it is really a bunch of nonsense.
What's being produced by these autocatalytic reactions at the end point?
Nanoparticles and then micron-sized particles at best, which he calls houses and skyscrapers. So he gives the impression to the layperson.
Are they sugars, nucleic acids, proteins, or lipids?
No.
Any of the four major, are they the building blocks of those?
No, they're metal oxides. They're just like rust on a piece of metal.
So why are any claims being made about prebiotic relevance for these products of these reactions?
Because it's nonsense. Because it's utter nonsense.
I mean, is it viewed as in some way analogous to some process that would have to happen? Is that why it's being claimed to be prebiotically relevant?
There's zero relevance. There is no relation. No relation at all. And then we can get into his little bubble.
Yeah,
chemistry.
I wanted to ask you about the droplets, because they look superficially relevant. You got a little droplet. It looks like it might be a cell. hey presto, now we're cooking. What's wrong with? First of all, what does Lee Cronin claim about these experiments that he's done with the oil drops, and why are they or are they not relevant to prebiotic processes and actual lipids, for
Okay,
example?
so Lee Cronin is claiming an autocatalytic reaction to make something that's analogous to an oil. An oil, or where he would have a non-polar tail and a polar head. Polar head meaning that it would dissolve in water. Non-polar tail does not dissolve in water. This is sort of like a soap. A soap has a polar end that dissolves in water and a non-polar end that interacts with the oil that's on our hands, grabs that oil, and then the head pulls it into the water solution, and that's what washes it off our hands. He wants to make something that's analogous to a lipid that is going to be needed for a lipid bilayer. You have to have a diaceal. You have to have two tails coming off. The one tail would never be stable enough. He makes it with one tail. He calls it lipid-like. It's not lipid-like, but let's just give him that.
It's
And
not
he
lipid-like because it doesn't have two tails.
doesn't have two tails. And also so he says that this is prebiotically relevant. And then you go into his own paper and you read the steps that it took him to make that lipid-like molecule. It took him 10 pages of synthetic organic chemistry steps using all modern techniques, multi-million-dollar pieces of equipment to make the molecule to set up to make that lipid. So that in the last reaction, he just reacted it in water and it did a condensation reaction. You see, he says, it's such simple chemistry. This would form on an early Earth. But the chemicals you needed to set up that key little step that happens in a condensation reaction that
Took
could
you
occur.
10 pages of synthesis.
10 pages of synthesis. Where is that going to happen on an early Earth? Who knows? It's not going to happen on an early Earth, so I'm calling him out on it. Poor Dave Farina, again, poor man. He couldn't look at the experimentals. He had no way to assess the experimentals. You have to click on that. The experimental sections come up, and then you read it and you go, oh my goodness, this is all modern synthetic chemistry. That's what I do. And this is this type of things my students, my graduate students, my postdocs do in the lab. 10 pages of synthetic chemistry to set up for the one little reaction that he says is going to make this lipid. Then, after he makes the lipid, they naturally assemble into these oil droplets. It's just oil and water. Now, what happens is when an oil droplet grows, it undergoes something called the Marangoni effect. It grows to a certain size, and then it bursts. It bursts because the surface, the free energy of the surface, it's called the free energy of the surface, becomes so high that now it minimizes by bursting open and going into smaller bubbles. In the process of doing this, it moves around in the solution. It is an experiment that you do for children in an elementary school, where you take a bunch of oil, you put a little bit of a surfactant on it, and it bursts up into bunches of little pieces. You can do this at your kitchen sink. You take some oil that's in a pan because you were frying something and now you've put water in there and there's this oil layer on top. You put one little drop of a surfactant and it'll break up. This is, in a sense, doing something similar to this, but here rather than using a surfactant, it's just the natural forces that these grow big enough, they're going to burst. He says this
so
is like...
does he claim this is analogous to cell division?
Yes, he says this is analogous to cell division. Oh, in a cell division, there's a huge orchestrated series of events that has to occur. The DNA has to be duplicated and some goes to each side. And then all the different pieces have to be duplicated and go to each side. And then right in the middle, the thing begins to pinch down in this orchestrated event. So none of that is there. He has nothing inside these. Nothing is moving to either side. And he says because it exploded and went, this is like cell division. And you see that? He's getting these things to form and then cell division. It is an elementary school Marangoni effect, and he's calling cell division. He's not the only group to do this. There was a group a few years ago at Harvard that did the same thing, Marangoni effect, and he said that this was analogous to cell division. That's what these guys do. And their lipid bilayers could never be used because their inner layer and their outer layer of the lipid bilayer is the same. You don't get a proton gradient. That could never be within a cell. None of this works, and he
And
speaks
the proton
about this.
gradient is important for passing the correct materials through the lipid bilayer in and out, correct?
Correct. You can't have a living cell.
So this isn't an optional feature of a lipid bilayer or cell wall.
Right. It's nothing that it could evolve into later as it got better. It's not going to work. It's not going to work in the beginning. And this whole thing of just taking a vesicle and having it grow to a certain size and then it bursts and starts moving in solution. You see these things wiggling around in solution. You go, wow, it must be alive. It's moving. I'm telling you, take a little bit of oil on water in your pan, in your kitchen with the light shining on. Take one little drop of the dish cleaner and just drop it right in the middle. You see this thing just scatter. This is the same idea in the sense that you're just getting an oil droplet to break up. And he makes this amazingly wild claim that this has something to do with life, and poor Dave Farina buys into it. And that's why he's the victim. He's the victim of what these guys are teaching. Dave Farina is the victim. We need to feel bad for him.
And just to go back to the earlier step, these 10 pages of specifications for synthetic chemistry, that's equivalent to a kind of recipe, right? And so essentially the claim is, I've baked a cake without any intelligent design, but I've used this recipe to do it. And I've followed the recipe step by step. But so they're not simulating an undirected process. At every step of the way, they're directing it in accord with a plan or a blueprint. Correct?
Steve, you're being way too nice. When you look at the details of this experiment, many of the steps are done under an inert atmosphere with no water, no oxygen around. They could never work with any water, with any oxygen around. They have to be done in a very pure, inert gas environment. And
so there's really two problems, and they are not simulating an undirected process, and they are not simulating a process that could have taken place on the early Earth, because the conditions that they set up in the laboratory don't match what was on the early Earth. So they're not simulating what they claim to be simulating.
It's not even that it doesn't match what you couldn't do on an early Earth. It's doing chemistry you couldn't even do until the 1950s. It's that advanced. It's chemistry that can be done only in a modern laboratory. I mean, this is crazy hard chemistry. Then, the other thing I've said, after every step, you always have to do the analysis. You have to analyze what you've got. So at each step, he's using several pieces of multi-million-dollar equipment to do the analysis. First, they do the separation using advanced instrumental methods, and then they use multi-million-dollar pieces of equipment to discern what they've got after each step. Where is that on an early Earth? It's not there. It's not there.
It's critical, right, to characterize what you've got, because
or else you don't know,
and then you don't know how to proceed to the next step, right?
That's correct, and you don't know if it's pure. None of this works. This is all smoke and mirrors, Steve. It's all smoke and mirrors put forth by these guys, and that's what I expose. So the first 3 videos in my series are dealing with Lee Cronin. Now Dave gets dealt with just as collateral damage along the way. And then there'll be others.
It is nice that he's brought these experts in to support his claims, because it gives you the opportunity to have an expert on expert conversation and not have to pick on this poor guy, because he does. I mean, he comes off rather aggressively, but as you say, it's clear he doesn't know how to evaluate the underlying science that supports or doesn't support the claims that these experts are making. And fortunately you do, and that makes for a much more interesting discussion. So and I can't recommend to our audience enough this new series that you have coming out. It's not only scientifically really very, very rigorous, but it's pretty entertaining to watch as well. It's well produced.
It's very well produced. I have a producer, Eric Heron, with Philosopher Films, that just did a great job, because my first series was a lot more mundane. I was just teaching, if you want a good teaching on the basics of chemistry that you need to understand origin of life. It's all there. It's up on the internet free. If you just go to my YouTube channel, Dr. James Tour, you can see it there. You can either listen to it in 14 different parts, or that now there's just a one video, 9 straight hours of video you can listen to. But this one, Eric's done a great job in just bringing in a little bit of humor in this. So it's, I think, much more watchable to the layperson.
Well, we will be having a bit of a little write-up about the video on our Evolution News and Science Daily. We will, in that write-up, embed the link to this video, and we'll also have a link to the new video that you're the first of your series as it comes out, and we'll be highlighting the additional ones as they come out as well. One of Dave Farina's selling points is that he's a science communicator, and one of the things I love about the origin of life debate is that it is a debate that is inherently interdisciplinary. There's chemistry in it, there's biology in it, there's an analysis of thermodynamics in it. You have to understand something about the information sciences and information theory. And there was a famous scientist, Dyson Freeman, who said that the origin of life is a debate for the scientist who has a little bit of everything, who's interested in all these subjects. And one book that we've done that highlights that is called The Mystery of Life's Origin. This was originally published back in 1984 by the authors Charles Thaxton, Walter Bradley, and Roger Olson. And we have recently re-released it with 5 supplementary essays, one by Dr. Tour, addressing the organic chemistry, the organic synthesis problems, one by Brian Miller, looking at the thermodynamic problems associated with the origin of life, one by yours truly, looking at the information problem associated with the origin of life, and then 2 other essays, one by Jonathan Wells and one by Guillermo Gonzalez, who is addressing the field of astrobiology. So we have an interdisciplinary critique of these chemical evolutionary theories and a reflection on what it all means in this new book that nicely complements, I think, what Dr. Tour is doing. So we highly commend his videos to you, in part because if you're trying to think about the origin of life, you're going to inevitably have to learn about a lot of different types of science, certainly a lot of chemistry, but other fields as well. So we're delighted to be able to highlight those videos. And as I said, we're delighted that this debate has broken out on the internet, because I think it will bring eventually more light than heat as we think about this really profound mystery, which is, how did life begin on planet Earth? Jim, we're really delighted that you took the time to talk with us today. We'll be doing a subsequent interview, and thanks for coming, and we'll be hoping lots of people watch this new video series that you've produced.
Thank you.
The fact that the chemists in their laboratories were making it happen. They were mixing A with B, and then mixing C in just the right amount. It's like cooking a dinner.
Yeah, recipe.
It's one thing to follow a recipe and cook up a dinner. That's another thing to let a wild boar into the kitchen.